Rashali.
I'm Sierra.
And here's Tim with the weather.
Thank you. It's your boy Tim, PhD Weatherman, doing what the weatherman does. Let's check some temperatures. This is 37 degrees. Mimics the human body. Perfect condition for cell growth. Let's look inside. Looks good. Check the humidity. Ooh, it's humid. It's good. Perfect day to take out your kids for a walk. This is our liquid nitrogen freezer. It's at minus 160 degrees Celsius. Let's look inside. Ooh, foggy up in here. You might want to turn on some headlights. Okay. Thanks. Back to you.
Wow, Tim, that was so amazing. I can feel the cold here.
Well, that could be because the air conditioner is on.
Oh, well, enough with the cold, because we are bringing in something hot.
And hot it will be, with Chet's amazing cell race. Chet?
Thank you. We are now here at the clinical laboratory in downtown Sacramento to see which mesenchymal stem cell will become the next ultimate divider. Here at the laboratory, these cells are tested to see if they can differentiate so we can validate them as MSCs. Now, back to the race. It looks like so far the adipocytes are differentiating at a faster rate. According to our sources, this is no surprise because fat is usually easier to grow than bone. This is why the osteocytes have fallen so far behind. Chondrocytes, however, are on a race of their own, as they were disqualified earlier for not following proper 12-well procedures. Now they race in their own private conical tubes. This race may take a few weeks, but we promise to keep you updated here at the clinical laboratory.
I just don't understand, Sierra.
Understand what?
How they can manage to maintain a facility so beautifully.
Well, the IRC GMP facility is amazing, and it is kept to the highest standards.
And today, our viewers will get once-in-a-lifetime view of this very facility. Matt and Maria.
Thank you. Hello, I'm at the IRC GMP facility. GMP stands for Good Manufacturing Practice. We got a special entrance into the facility. This special part of the laboratory is where all the manufacturing and cell culturing is done that may go directly to the patients. To enter, you must suit up to reduce contamination. This facility maintains sterility by specific room pressure monitoring, following of enter-exit protocol and daily cleaning. This lab also has state-of-the-art equipment including a high-power microscope and a hollow fiber bioreactor that produces more than 1 billion cells per run, compared to culturing flasks that produce 1 million. These GMP facilities are key to maintaining sterility when making pharmaceutical drugs and supplies. Back to you.
I hope you don't get claustrophobic in that bodysuit.
Just switch to the vector.
Thanks, Rashali. Here we are at the Institute for Regenerative Cures in the Vector Core. Here in the Vector Core, we design many different vectors for all the different teams of our facilities.
Vectors are really important because they're used in gene therapy in order to deliver corrected versions of the genes to a patient.
Right now, I'm loading a mini prep for one of the many vectors we designed for all of the teams here at the UC Davis facility, such as the Huntington's disease team, peripheral artery disease, critical limb ischemia, HIV, and many others. We have vectors for almost any disease you can name.
So the way we do it is we have plasmids containing different components of a vector, and we transfect cells, and these producer cells produce our final product. Back to you, Rashali.
That was so interesting, Hannah.
Let's switch over to Jane and David.
Hi, I'm here in the lab with Jane and David to talk about mesenchymal and induced pluripotent stem cells. What are mesenchymal stem cells?
Well, mesenchymal stem cells are multipotent cells that can differentiate into other types of cells. Although they can't differentiate into all, they can, under the right conditions, they can differentiate into bone, cartilage, fat, and muscle.
What are induced pluripotent stem cells?
Induced pluripotent stem cells are adult cells that have been genetically reprogrammed with the 4 Yamanaka factors into an embryonic-like state.
Alright, back to you.
Thanks for watching Stem Cell Live.
Recording.
Okay, thumbs up. Alright, that's good.